an important outcome of this process is a general description of how we move cash flows forward and backward in time. And I'll show the formulas really quick here. And this is the formula here that defined how we got to our $104.76 number. And notice that it starts with the future, $110. That's $110 in year one. And then divides by a 1.05. That 1.05 we derived from the market rate of interest on a one-year loan. That 1.05 is a discount factor. That's the name we give it. And the market rate of interest over that year defines the discount factor for taking year one cash flows and pulling them back to year zero. Vice versa, if we had $104.76, we can take it forward in time to year one by multiplying by 1.05. If I had the formula, you end up at the same place. Nearly. That's some rounding error there. So the discount factor is a thing that takes you through time, and it's defined by the market rate of interest. So let's think about if I have $100 in a checking account today, and the market rate of interest is 5%, that means my discount factor is 1.05. And if the market rate of interest every year, from year 0 to year 1, and year 1 to year 2, and so on, is always 5%, then a year 0 cash flow of 100 should be equal to a year 1 cash flow, or excuse me, a year 1 cash flow should be equal to a year 0 cash flow times the discount factor. And so if I have $100 today, and the discount factor is 1.05, that is the market rate of interest over 1 year, is 5%, then the year 1 cash flow should be 105. But we can do the same process for years 2 and years 3 and so on. So this is the miracle of compound interest as we're paying interest on the interest, and it starts to get bigger and bigger and bigger. And we can do, if we do a nice line plot of that, let's make that a little more manageable. There's a picture of our money growing, and as we change the discount factor, what if actually it was an 8% per year? Well, now we get a steeper slope to our curve, and if we go even higher, now we get a much stronger exponential growth. So the discount rate moves money forward and back, and is defined by the market rate of interest over that year. So, and it works just as well backwards and forwards. So if I have $2,893 in year 10, that's the same as $100 in year 0 if I have a 40% interest rate or 1.4 discount rate. We can do the same thing working backwards from 100 here. So if I'm going to get $100 in the future, I can take that $100 and divide by, the discount rate. Let's make it something more reasonable, like 5%. And then, and fill up to year 0. So you get the same picture. And now we're starting at 100, and we go back and end up at 6139. This is a common operation that we'll be doing in finance, converting cash flows from one time frame to another. And the reason is pretty straightforward. So when we're thinking about businesses make money, and they make money continuously throughout the year. and over multiple years. And when one invests in a company, you're not buying access to the cash flows this year or next year. You're buying access to cash flows forever when you purchase common shares. And so with annual reporting, we have year zero cash flows and year one cash flows and year two cash flows and so on. And so if we're trying to value a company or a business or an idea, it's likely it will have a series of cash flows occurring in multiple years. And therefore, if we need to know how much we're willing to pay today for a package of cash flows that includes some money today, some money tomorrow, and some money far in the future, we have to have a systematic way for converting that future funds flow into a value at today's prices.